Myself, V. Sai Teja. I am from Electrical and Electronic Engineering Triple Department. Subject Analysis of Electrical Network. Today, Tech Talk topic is about steady state analysis of a two branch resistance inductance RL parallel circuit controlled by a forced commutation bidirectional AC switch. Steady state analysis of a two branch resistance inductance RL parallel circuit controlled by a forced commutation bidirectional AC switch. Introduction. In electrical engineering, RL circuits are fundamental component in various applications such as filters, oscillators and power supplies. Understanding their steady state behavior is crucial for optimizing performance in real world scenario. This document focuses on a two branch RL parallel circuit controlled by a forced communication bidirectional AC switch, exploring its behavior under steady state conditions. The bidirectional switch allows for efficient control of AC power flows, making it particularly valuable in modern power electronics. This is, this, uh, this is the introduction of steady state analysis of a two branch RL parallel circuit controlled by a forced commutation bidirectional AC switch. Electrical circuit fundamental. Electrical circuit theory provides the foundation for analyzing the designing circuit. Fundamental laws such as Ohm's law, V is equals to IR, and Kirchhoff laws guides the behavior of current and voltage in circuit. Kirchhoff current law (KCL) states that total current entering to a junction is equal to total current leaving the junction, while Kirchhoff voltage law (KVL) states the sum of electrical potential difference around any closed network is zero. Steady state analysis. Steady state analysis focus on long-term behavior of a circuit after transient effects have died down. In RL circuit, steady state conditions occur when the current and voltage reaches constant values, usually influenced by sinusoidal AC source. This analysis is crucial for predicting how circuit will respond to a various inputs. Electrical circuit fundamentals. Resistance inductance circuit RL circuits. An RL circuit consists of a resistor is denoted by R and an inductor is denoted by L, connected either in series or parallel. The inductor stores energy in the form of magnetic field. When current flows through it causes a phase shift between voltage and current. The total impedance is denoted by Z in a RL circuit, can be expressed as Z is equals to R plus J omega L. Here J is the imaginary unit and omega is the angular frequency of input AC voltage, and R is the resistance of a resistor and L is the inductance of a inductor. Bidirectional AC switch. Bidirectional AC switch are crucial in controlling AC circuits. They can conduct current in both directions, making them ideal for application requiring rapid switching and control. Forced commutation techniques enables these switches to turn off even when the current is flowing, improving circuit reliability and efficiency. This is the circuit diagram. Here, resistor and inductor are connected parallel across the sinusoidal voltage source. The currents in the resistor, the current is in the phase of voltage. In the inductor, the current lags the voltage by an 90 degrees. In this graph, we can see here the blue line are the voltage, green line are the current of the resistor, red line is the voltage of the inductor. Inductor lags the voltage by an 90 degrees. The resistor of the current is in phase with the voltage. Components. Resistor. These components limits the current in the circuit and determine the power dissipation. Inductor. This component stores the energy in the form of magnetic field and introduce reactance affecting the overall impedance. The impedance is denoted by Z, bidirectional AC switch. This component controls the current flows through the branch, enabling forced commutation. Mathematic modeling. Kirchhoff law. Applying KCL and KVL allows for setting up equations that governs the circuit behavior. For example, KVL can be applied around each loop to establish relationship between voltage and current. Impedance calculation. The total impedance ZT for parallel RL circuit can be calculated using the formula 1 by ZT is equals to 1 by Z1 plus 1 by Z2, where Z1 are the impedance of Z1 and Z2 are the impedance of individual branches, and ZT is the total impedance of the circuit. Current and voltage analysis. Using phasor analysis, the voltage across each branch can be expressed in the terms of the total current. IT is equals to I1 plus I2, where I1 and I2 are the branch's current. The phase relation are critical for understanding how current and voltage interact. Forced commutation bidirectional AC switch. Operational principle. The forced commutation switch operation by actively turning off the switch during specific interval regardless of the current flowing through it. This is achieved using additional circuitry ensuring that the switch does not enter a continuous conducting state, which is essential for preventing circuit damages. Switching characteristics. The switch exhibits rapid switching capability, allowing for efficient modulation of AC signals. Key parameters include turn on and turn off, which influence overall circuit performance. These two are the forced communication bidirectional AC switch operational principle. Switching characteristics. Analysis of steady state condition. Phase relationship, frequency response. In a two branch RL circuit, the current and voltage in each branch will generally have a phase difference. The phase angle is denoted by phi. Can be determined using tan phi is equals to omega L by R. Here omega L is the inductance of inductor and R is the resistance of resistor. Frequency response. The circuit response varies with frequency. Analyzing the frequency response helps identify resonant condition and optimize circuit performance for specific applications. Simulations and result. There are many softwares can simulate the RL circuit. Using simulation softwares like MATLAB or Spaces, the RL circuit can be modeled to visualize the voltage and current waveform. The simulation should accurately represent circuit parameters. Analysis of output waveform. The simulation result will typically display the current and voltage waveform, illustrating how they behave under steady state condition. Important characteristics such as peak value, RMS value, and phase angle can be extracted. Here in the y-axis we can take the current, voltage, RMS values, phase angle. In the x-axis the AC voltage is in the x-axis we can take the time t. Comparison of theoretical and simulation result. That theoretical results should be compared with simulation output to validate the models. This discrepancies can be analyzed to refine the understanding of circuit behavior. Applications of RL circuit with forced commutation switches. RL circuit with forced commutator switches find applications in various areas including motor drives, power supplies, inverters. Motor drives controlling the speed and torque of AC motors. Power supplies regulating voltages and current in switched mode power supply. Converting DC inverters converting DC to AC power efficiency for renewable energy applications like solar power. Conclusion. The steady state analysis of a two branch RL parallel resistance and inductance parallel circuit controlled by forced commutation bidirectional AC switch provides valuable insight into its behavior under various conditions. Understanding the interaction between resistance and inductance and switching technology is crucial for optimizing circuit performance. This analysis is not only fundamental to theoretical study but also practical implication is designing efficient electrical systems. Thank you.